Alright guys, we're back again in 11.3 to prove that lines are parallel. So to do that, we're going to use the converse of our corresponding angles theorem. And what that means is instead of knowing that the lines are parallel and then knowing about the angles, we will first know about the angles, and that will tell us that the lines are parallel. So here, all you need is two corresponding angles, which will make up one pair. We could also have corresponding angles here and here, or below and below, or off to the left and below and left and below. Look at 1 and 2 and try to figure out if you can figure out which lines or segments are parallel. So you can extend the lines if you need. That's always a good technique. Just give it a shot. When we compare the location, we can see that the 45-degree angles are both above this line here on the bottom, and then they both lie kind of to the left, below, however you want to look at it, to my line CA and HR, which there's my pair, so that means that CA is parallel to HR. Try number 2 if you have not yet. So my shared line now is the line at the top. My two other lines that make up the angles are RK and TM, so we can say that RK is parallel to TM. So this then brings us to our next 3 theorems. We have the converse of our alternate angles theorems. I think you guys can figure out how this is going to work. If I see alternate angles as congruent, then that proves my lines to be parallel. Same with the converse of the same side interior angles. If two angles inside on the same side of the transversal add up to 180, then it proves my lines to be parallel. And the converse of the alternate exterior, again, these should be congruent. If they are, then my lines are parallel. And then we have a flow proof to show that Theorem 10 holds. And we could write one of these for 11 or 12, and we will for 12 in a moment. But we are given that angle 4 is equal to angle 6, so those are my alternate interior. Then I see that angle 2 and angle 4 are equal because they're vertical angles. That means that angle 2 must equal angle 6 by our transitive property. I can just replace angle 4 for 6. And then that proves to me that angle L is parallel to, or not angle, but line L is parallel to line M. In example 3, we can prove this a few different ways. We're trying to write a proof for Theorem 12. So it's once we write the proof, then it holds true. So we could look at this and say 1 and 3 are vertical angles, 5 and 7 are vertical angles, 3 and 6 are an interior pair, so if these are parallel, then they would equal 180, but we can't use that till we know it. Easiest thing probably to do here would be use the fact that 1 and 5 are corresponding, which then means that their angle measures would be the same, and the fact that 5 and 7 are vertical, so their angle measures would be the same. We can use the transitive property to replace and say that angle 1 is equal or congruent to angle 7, which proves our lines to be parallel. So now we want to fill in the missing parts of our flow proof here when we start knowing that 1 and 3 are supplementary and we need to prove that A and B are parallel. So go ahead, pause the video, try to fill in all the missing sections. I forgot, I gave you a couple. I gave you the completed version in your notes. So as we walk through this, 1 and 3 are supplementary, so they add up to 180. 1 and 2 also must be supplementary, which then by the transitive property or definition of a linear pair, we can substitute in and say that 1 and 2 must be supplementary. When we start 5 and 6 here, we know that L and M are parallel, so we're going to find the values of X applying our theorems that we just learned. Pause the video, go ahead, give this a shot. Since these angles here are alternate exterior, we know that they would be congruent, so we can set up an equation here, and then we'll solve the equation to find our X. And when we solve, we find X to be 59 degrees. Over here, it's a little bit more complicated, so take a minute and try to solve that out. From looking at what actually matters, we can let go of this line right here. It really isn't doing anything for us. We see that the 3x minus 18 and the 105 would actually be supplements of each other and add up to 180, and then we can use algebra to solve from there. And when we write it all out, we find that X would be equal to 19 degrees. So that is all I have for you guys today on 11.3. So stay tuned for the other videos if you're keeping up to date. Please make sure you work through all of the Pearson module and tried your practice work, and let me know if you need anything. Thanks and have a great day.